All right, a recap in 4.5, graphing inequalities. Okay, real quick, the first thing you need to know is when you're graphing inequalities, if you have a less than or greater than symbol, it's always going to be a dashed line, okay? That just says it does not include in that line. When we're talking about inequalities, we have infinite answers, okay? So we're going to have either everything above the number 1 or everything below the number 1 and the x's. It's going to be any number larger than 1 you can think of. So that's infinite solutions. There's decimals, there's fractions. So we're going to have infinite solutions. So therefore, we're going to have to shade what part of the graph is going to be the infinite solutions. All right, so less than, greater than are going to be dashed lines, or equal to are going to be a solid line. Okay, that just means everything that's on this line you can include. The dash means you cannot include anything on that line. All right, so let me give you a problem. We have x plus y is greater than or equal to 4. All right, so there's lots of different ways. However you like to graph. You do it however you like to graph, whichever way is your favorite method. My favorite method is solving for y equals mx plus b. So that's what I want to do because that's my favorite method of graphing. So I need to solve for y. So I need to get that x on the other side. So I'm going to subtract x to both sides. Now I have y is greater than or equal to negative x plus 4. All right, is that in the y equals mx plus b form? Yes. So what is my m? Well, there's an implied 1 here, right? You can do 1 times x, or you can just say x. It means the same thing. So what is our m? What is our slope? Our slope is negative 1. It's always the number with the x. So our slope is negative 1. Remember, slope is a rise over a run. All right, so how can I turn that into a fraction? Negative 1 over 1. So what are we going to do? We're going to rise negative 1, which means we're going to go down 1. And then we're going to run positive 1, which is to the right 1. All right, that's just the slope. Now let's find what our b is. What is our plus b? Remember, our b is always our y-intercept, and it's always 0, comma, something. Well, what's the something this time? The something is positive 4. So our point is 0, 4. So we have enough to graph now. So let me go ahead and draw my little, use your imagination. It's supposed to be pretty good, but it's not. All right, so let's graph our one point that we have. We only have 1 point. Our point is 0, 4. So let's graph 0, 4. 0, 1, 2, 3, 4. So our first point is in our y-intercept. It should be, right? Because that's what we know. It's a y-intercept. Okay, and from that point, we're going to do our slope. Down 1, right 1. Down 1, right 1. We could do this over and over. Now, is this a dashed or a solid line? When I connect these dots, I need to know, is it dashed or solid? Okay, well, let's look at our symbol. Our symbol is or equal to, so since it's or equal to, it's going to be a solid line. All right, so we have it graphed. However, where do we shade? Well, when you want to shade, you're always going to pick a TP, test point. Okay, you need to find a test point, and it cannot be on your line. It needs to be below or above your line. Excuse me. My favorite test point is 0, 0. If it's not on the line, I'm picking 0, 0 because it's easy to add and multiply by zeros. So I'm picking 0, 0 because it's not on my line. It cannot be on my line. And I'm going to take the original equation up here. What was the original equation? It was x plus y is greater than or equal to 4. All right, so but in place of x, I'm going to plug in what's my x. My x is 0 in my test point, and my y is 0 in my test point. So it's going to be 0 plus 0 is greater than or equal to 4. Woo, excuse me. Excuse me. All right, is 0 plus 0 greater than 4? No, 0 is greater than 4. That is false. So therefore, we cannot shade on this side. Well, there's only one other side I can shade on. It's either above or below. Well, if my test point comes out false, then we're going to shade on the opposite side of the test point. So if my test point had become true, then I would shade everything down here if 0, 0 was true. However, 0, 0 is false, so we cannot shade on this side. We have to shade on the other side. So therefore, everything above will be true. Again, if your test point comes out true, shade on the side of the test point. If your test point comes out false, shade on the other side of that line.